Let's begin with the collaborative problem for superposition in the frequency domain. So the question is this. To solve this in the frequency domain, we first observe that there's two separate frequencies. Here, omega is 10, and here, omega is 0. So we cannot convert this to a single schematic in the frequency domain because there's two different frequency domains, one at omega 10, one at omega 0. So this requires us to use superposition to solve. So let's solve first using the left source on. And then we'll solve using the right side on. So with the left side source on, our omega is going to be 10. The right side source, our omega will be 0. With the left side source, the impedance of that inductor is always j omega L. So that will be J15. Our impedance of our capacitor is always 1 over J omega C. So that will be 1 over J 100 millis. And that's the same thing as multiply top and bottom by J, and we get minus J. We can bring that J to the top. And 1 over a tenth is 10. The units of these are actually ohms. And so now we can redraw our circuit. We have a phasor 10-volt source. And our goal is to find this current, capitals now because we're in the phasor domain. Since the left side only is on, the right side, the current source, we replace with a 0 amp current source, which is the same thing as saying it's open. So therefore, the voltage source sees the equivalent impedance, I'll call it equivalent, of these two in series. Plus the next two in parallel. And that's the total amount of impedance that this voltage source sees. And then we can divide 10 by that impedance defined I. So let's simplify this. Product over sums says we've got minus J 100 over the sum. In the calculator it goes, now it comes this phasor. 14.1 ohms at an angle of 45, so that's a complex number. And then our I has to be our V over ZEQ, or 10 over 14.1 at an angle of 45 degrees, or 0.707 at an angle of minus 45 degrees. So now we can transform it back into the time domain, and that's a current. So this is our first partial. Sub 1. There are two ways we can handle the source on the right. We can go back to the beginning of the course and say whenever we're presented with a DC source, capacitors are open, inductors look like shorts. Or we can continue doing what we did on the left and say Z sub L is always equal to J omega L. And when omega is 0, we just get 0. Z sub C is always equal to 1 over J omega C. So when omega is 0, we get infinity. And that's really just the same thing as saying an inductor is short up here and a capacitor is open. Drawing this circuit in the frequency domain with only the right source on means we will short the left source. This becomes a 0-volt source, which looks like a short. I'll draw these things on the left. This becomes 0 in that domain. The 5 ohm stays. Our capacitor looks like an open. And this resistor stays. And our current source remains. And we are looking for how much current is here. Maybe just to make it clear that these are partials, I'll call this I sub 1 and I sub 2 for the second partial. So I look at this circuit and I see current flowing through this loop, and I also see current flowing through that loop. So one current source with two resistors in series tells me it's a current divider. So therefore I2 would be equal to the source times the other one in the numerator over the sum. But that's not quite right, because this current source is pushing the current in the opposite direction of how we defined our I sub 2. So we need to put a negative sign in front of it. And now we can simplify this, and that's just minus 2. And so our partial second current is going to be minus 2 amps. And that means we can finally solve the entire circuit. The total current is equal to I1 plus I2 is equal to this amount of current from our 10G, from our omega 10 source, minus 2 amps from our DC source. And that's the answer. Now notice you can't accidentally add in the frequency domain. You can't accidentally add this phasor to this phasor, because if you tried, you'd end up having to plug in what omega is, and you wouldn't be able to find a single omega for both of those. And so that would be the signal that you've got to first convert back to the time domain before you add them together.